let's talk about the last section, last part of section 4.5, comparing growth of functions. And sometimes you see as f of x as the limit of f of x over g of x as x approaches infinity is equal to infinity. Sometimes you see the limit of g of x over f of x as x approaches infinity is equal to 0. This, what it means is that as we go toward infinity, one of them grows much faster. And so one of these examples is compare x to x squared. X is the line over here, and then the x squared is the fast growing parabola. So they get really far away from each other. And so with how we show this is x squared is much bigger than x. That means as we approach infinity, one is growing a lot faster. One important case that we figured out as we were doing the L'Hopital rule, we just saw that x to power, and we can prove that x to power n is always much less than e to the power x. So e to the power x is more powerful than any polynomial as x approaches infinity. And then what the other thing that we saw is that in fact, for a bigger than 1, a to power x is much more powerful than x to the power n. And it just grows much faster. And we saw that any x to power n grows much faster than anything logarithmic in base a. Now, for the last question, we want to make sure that it's understood that sometimes it's easier to use a combination of L'Hopital rule and other rules that you know to calculate the limits. Over here, if I use the L'Hopital rule directly, see if I plug in 0 and 0 on top and bottom, I get 0 over 0. But if I use the L'Hopital rule directly, it's going to be really difficult taking derivative. One trick that I can use is to separate things that I think are about the same weight. So what I do is I put tangent of x over x, and then I put limit as x approaches 0 of sine of 5 over x over sine of 7 over x. And then I will get two limits of infinity, 0 over 0 and 0 over 0. And I just have to hope that both of them have a limit. Otherwise, this was not a correct method to use. And if they have a limit, then you're okay though. So it's always kind of risky, but then you have to go back and correct it if you made a mistake. So in this case, I get, using the L'Hopital rule, I get, what's the derivative of tangent? It's secant squared x over 1. What's the derivative of sine of 5x? It's 5 cosine of 5x. And derivative of sine of 7x is 7 cosine of 7x. As x approaches 0, cosine of 5x is 1, cosine of 7x is 1. What you're left is 5 over 7. And secant of 0 is 1 over cosine of 0, which is 1. So the entire thing becomes 5 over 7. So sometimes it pays if you use combinations of methods to calculate the limits. And this is much easier than just doing L'Hopital rule once without any separation.